Welcome, and I hope that you tighten your belt for this particular interesting journey that is all about linear programming. And we are going to concentrate on this particular method, that is the simplex method, away from the graphical method that I've actually prepared a video for you. Kindly check on the playlist quantitative analysis and operations research. Now, our problem is an adapted question from KASNEB May 2015, question 5C, in which we are actually supposed to do some element of optimization, that is the maximization of revenue. And before we look at actually the steps that we are going to follow, I would like us to go through the question briefly to be able to acquaint ourselves on what we are supposed to expect. Now we are told that the following data relates to raw materials required for the production of each unit of two products A and B. So we're supposed to produce product A and B, and raw materials in kilograms are X and Y. So it means that these particular raw materials are the limiting factors. They are scarce resources. For product A we require X, and for product B we require 4 kilograms of X. Then for product A we require 7 of Y and 2 units of Y in product B. Then we are told further that the available quantities of raw materials X and Y are 300 kilograms and 400 kilograms respectively. So it means 300 kilograms is available from raw material X, both in A and B, as well as 400 kilograms available for material Y, that is in both A and B. So it means that we are going to construct an equation that is going to illustrate that particular information. Then we are told the unit contribution of products A and B are 140 shillings respectively. So it means that the contribution per 1 unit of X is 100 shillings and per 1 unit of Y is 40 shillings. Now, because now we are given the contribution per unit, this is actually a problem involving maximization. So the question says, using the simplest method, determine the number of units of product A and B that should be produced in order to maximize the revenue. So our main concern here is actually maximizing the revenue. So away from anything else, I would want us to recall this particular session that we are going to deal with, and we are dealing with a problem that involves optimization. Remember that in linear programming, optimization could always involve two things. It could involve either minimizing the cost or maximizing the revenue, or if you like, the profit. And in this case, our problem is revolving around maximization of revenue. Then, for us to look at all the steps that we're actually going to follow, I would want us to recall what is simplex method, which is actually an algorithm that gives an optimal solution in a number of finite steps. So the word algorithm here means this particular method involves an element of rules that are being followed in stepwise, and the word finite number of steps means the steps are always continuing until we reach an optimality, that is when we are going to stop. So the question is, how will you know that you have actually arrived at the solution? That is, we do what is known as the optimality check. So the point at which you will no longer proceed further with your calculation is when if there are no negative elements in the Z row. So the moment we don't have any negative element in the Z row, that is now when we have actually arrived at our optimal solution. So I would want us to, for us to understand what is a Z row, I would want us to actually formulate this particular problem. Now we have raw materials X and Y being required. It means these are resources which must be utilized in the proper way. In this particular method, we replace the available resources with slack variables. So we can talk about the slack variables now. Slack variables, which actually the unused resources, which must be utilized in the proper way to be able to actually maximize this particular revenue. And now you can say that let S1 be the slack variable in material A, then S2 to be the slack variable in material B. Sorry, so we actually replace those particular scenarios. Then we can now formulate an inequality, which are told that for X, for product A, we require 3X plus 4Y. That is for product B. So if we have 3X plus 4Y plus the slack variable in product A, this one shall be less than or equal to, because we are told that the available quantities of material X and Y are 300 kilograms. So there's no any particular point in which these particular available raw materials will be more than 300. So it must be less than 300 kilograms. Then now you go for Y, 7X for A, then 2Y for B. So we shall have 7X for A plus 2Y for B plus the slack variable in B should be less than or equal to 400. That is the available material in product Y. Then after we have known all these ones are the constraints. And remember, because raw materials are the resources, we normally have what is known as the negative constraint, which says that X plus Y should be more than or equal to 0. So it means there's no any particular point in this particular production that this particular company is going to lack its resources X and Y. Then essentially it means that we are going to maximize. So we are supposed to maximize the revenue or profit denoted by X, which should be equal to, because they are told that the unit contribution of product A, so 1 unit is 100, so it means for X, which is material A, should be 100X plus 40Y should be equal to that particular profit or revenue which is supposed to be maximized. Then from this particular working, we can now comfortably go through the steps and do what is known as standardization. Talk about now standardization. We are supposed to form this particular inequality such that we only have an equal sign. All the elements should be in one side, then having one particular 0 element in the other part, which essentially should be Z minus 100X minus 40Y should be equal to 0. And then of course these are the elements that are supposed to remain the way they are. So this is what is known as standardization. Then step 2, we talk about constructing the initial simplex table. So for us to construct the initial simplex table, we normally have this particular scenario. The contents are supposed to be solution variable, then we have product A, product B, we have slack variable S1, S2, then finally we have quantity solution. This is what is supposed to be solved. In this case, our initial table is supposed to contain these particular elements. So we're just going to copy paste what we have. Like you have 3. So our solution variable, the first one supposed to be solved will be S1, which represents A, and S2. If suppose we had 3 slack variables, we'd have had S1, S2, S3. Then we shall have 3, 4. Then we have the first slack variable, which is 1. We don't have this is 0. Then 300, this is the quantity solution to be subjected to. Then we have 7, 2. We don't have S1. Instead we have S2, so we shall have 1. Then 400. Then the last one is the Z row. This is now the Z row. And now we have this negative 100, negative 400. We don't have slack variable S1, S2, we don't have, likewise we don't have this. So this is our initial simplex table. And then we shall go to the next step. Optimality check. How do we check for the optimality? We check for the optimality. We will only arrive an optimal solution if there is no negative number, but in this case we have a negative number, so we shall go to the next step. We are told that if there is no optimal solution, we go to step 4. Then step 4 says you construct a new simplex table by considering these following elements. And this is now where the deal is actually. We are actually going to get the whole process from this particular aspect. Like we are told, sorry, we consider what is known as the entering variable, you consider leaving variable, you consider obtaining new pivot row, and finally the pivoting process. So if you talk about the entering variable, what do we mean by the entering variable? It has the most negative value in the Z row, and it identifies the pivot column. The Z row is this one. The number with the most negative value between these is this one here. So we are told that this one will identify the pivot column, and our pivot column normally run vertically. So this is our pivot column, as we are told. Then after knowing that, this one is the entering variable. Entering variable means this one here, the heading of this particular pivot row is going to replace the leaving variable. And what is the leaving variable? It has the smallest positive value when the right hand side values are divided by the corresponding elements in the pivot column. Okay, so when we divide the right hand side values, our right hand side values here are actually these one, 300, 400, and 0. So when you divide these, each value by its corresponding element in the pivot column, like 300 has the corresponding value of 3, 400 has 7, 0 has negative 100. And you should know that when you talk about division, when you are getting the leaving variable, division by negative values and 0 are ignored. when you're dividing a number by a negative value or a zero value, you're supposed to ignore that. Like in this case, we shall ignore that and retain this particular 0. So 300 divided by 3 shall have 100. Sorry, 400 divided by 7, we shall have a value to do with 57.1. Okay, so after doing that one, we are told that the living variable has the smallest positive value after dividing. So which one is small between these two? We have this one here. So this one identifies the pivot column, the pivot row, sorry. So this one is the pivot row, and our pivot row will now be the living variable. Living variable means now A is entering to replace S2. So if A is replacing S2, we are now supposed to proceed and get what is known as, we obtain now the new pivot row. And getting the new pivot row is the same as all pivot row divided by the pivot element. Pivot element is that value or element at the point of intersection between the pivot row and the pivot column. So we have this one here is the pivot element. Pivot element. So for us to get the new pivot row, we are told that we divide that old pivot row, this value, this row here, we divide 7, 2, 0, 1, 400 by the pivot element, which is 7. Everything divided by the pivot element. So we shall have 1, this is 2 over 7, this is 0, this is 1 over 7, and then this is 400 over 7. Like I said before, our new pivot row, this one here, our new pivot row should replaces the living variable, and our living variable is S2, which is being, so the heading will be A, but now the elements in A will be this particular values of the new pivot row for our new table as we proceed further. Then now we do what is known as the pivoting process after getting the new pivot row. Now to get the pivot under the pivoting process, to obtain new rows, we say that new other row is supposed to be the old other row minus the product of the pivot element times new pivot row. So pivot element times new pivot row, which you actually computed in this particular sector. And what we normally obtain is those other rows which are not being replaced. Like in this working, our previous example, you realize that we won't obtain another S2. Instead, we shall obtain S1, new S1 and new Z, because this one is being replaced by A. Sorry. So to obtain new S1, sorry, should be the old S1, which is 3, 4, 1, 0, then 300, minus the pivot element in that same S1, which is 3, minus 3 into the new pivot row that was computed, which is actually this one here, new pivot row of 1, 2 over 7, 0, 1 over 7, then you have 400 over 7. When you multiply this one, you're supposed to get, because this is 3, 6 over 7, 0, 3 over 7, then you have 1200 over 7. So we subtract this one. When we subtract, we are going to get the new S1, we shall have 0. When you subtract, we have a value of 0. We shall have negative 80 over 7, sorry, should be 22. This one should be 22 over 7. This one shall be 1. Shall have negative 3 over 7. This minus this should have a value of 900 over 7. Having that one in mind, we can go here and now get the other row, which is the new Z. So getting the new Z, we follow the same procedure. That is the old Z, which is actually negative 100, negative, this is 40, negative 40, we have 0, 0, then finally we have another 0 on the end. We minus the element in that same Z, which is negative 100, into new pivot row, the same new pivot row in this case, which is 1, 2 over 7, 0, 1 over 7, 400 over 7. When you multiply this one, is supposed to get minus 100. This time this is minus 200 over 7. This time this is 0. Minus 100 over 7. Finally we have minus 40 over 7. And then we minus these two. You get the new Z. This minus this is supposed to have 0. Minus this is supposed to have a value of minus 80 over 7. You have 0. You have 100 over 7. Then finally we have positive 40,000 over 7. As we can see, we are supposed now to form our new simplex table, and obviously our new simplex table is going to have some element of a positive value. So still we have not reached, or we have not obtained our optimality, because we still have a new positive value in our particular table. So new simplex table, you are simply going to copy paste what we have plus the row that was being replaced. Like you find that we are going to have an element of the same solution variable. So we shall have solution variable, shall have product A, product B, slack variable A, slack variable B, S2. Then you have quantity solution, because we shall have it in that particular format. So how our solution variable in this case will not be S1 and S2. Instead, we obtained our new S2. We obtained our new S1. So our new S1, which is the values are this one here, 0, 22 over 7, 1, negative 3 over 7, then you have 900 over 7. Then we can go to our new Z before we look at what we shall have here. So we shall get back to that. Our new Z should be 0, negative 80 over 7, 0, 100, and this is what makes it not to be optimal together with this particular quantity solution, the last one. Then after that, now we are supposed to know, we say that this new pivot row was replacing S2, so we shall have the values as 1 to 1, 2 over 7, we have 0, 1 over 7, 1, 0, 0, 1 over 7, and finally we had 400 over 7. And the heading here was going to be A, which was actually replacing, it was the entering variable. So after we have done the new table again, we now go to the processes. You iterate until optimality. Iteration means we are going to repeat the whole process until we will no longer have a positive value on the Z row. As usual, how do we begin? We obtain again the most negative value in the Z row, and it identifies the pivot column. We're just going to follow the same thing that you have been doing. So the most negative value is this one here. This one will be our pivot column. Then you divide each element in this particular pivot column by the right side values. And you divide this one the same as multiplying by the reciprocal. We're dividing a number the same as multiplying that number by the reciprocal. Over 22, this one is 7 over 2. And then we shall have a value to do with, this one should be something close to 450 over 11. And here we shall have 200. And then again, for us to get the leaving variable, we identify that particular row which has the smallest positive value, which happens to be this one here. So we identify this leaving variable. So as it is leaving, this one is entering, and it means that now the entering variable, its heading B, the heading B will replace S1 in our new table. It will replace S1 because this one is now leaving as B is entering. Then after that particular point, the only thing that we obtain is that those other rows which are not being replaced. Like you see now, we obtain new A and new Z. New S1 already we know that is going to be the new pivot row. So because it is leaving, we are supposed to get the new pivot row that will be achieved as soon as it is leaving. So we shall have the new pivot row. New pivot row. Now do you get the new pivot row? Should be the old pivot row divided by the pivot element. So old pivot row for this one is 0, 2 over 7, 1, negative 3 over 7, then you have 900 over 7 divided by the pivot element, which is 22, the element at the point of intersection, 2 over 7. When you do that one, shall have a value of 0, this one shall be 1, this one divided by this should be 7 over 22, this one divided by this should be a value of negative 322, then this one divided by this should be a value of 50 over 11. Kindly confirm with me to be able to ascertain our working. So this one will be the entries for that new row. Then now we get our new A. which is not being replaced. So getting our new A, the same thing, we shall have the old A, and our old A in this case should be 1, 1, then we shall have next 2/7, 0, 1/7, 400/7. We minus the product of the pivot element times the new pivot row. So we shall have our pivot element, which is 2/7 times the new pivot row times this one here, 0, 1, 7/22, 3/22, 450. So when you multiply each element here, you shall of course have 0. This one should be 0. 22/7. We shall have 1/11. Then finally here we have negative 3/77. Multiply this by this. Sorry, this one was supposed to be over 11. Multiply this one times this one should be a value of 900/77. Then of course we minus. When you minus, we shall get the new A. It should be here, should be 1. This minus this one should be 0. This should be negative 1/11. This minus this should be a value of 2/11. And this one this should give us a value of 500/11. Then the other thing to obtain is the new Z. Then now form the new table again. So getting new Z should be the old Z, which is 0, negative 80/7, 0, 100/7. It will actually be 0, negative 80/7, 0, 100/7, then 40,000/7 minus the product of the pivot element. So minus the product of the pivot element. Pivot element is negative 80/7. Negative 80/7 times new pivot row, which is actually this one, what you have obtained. This particular, what you obtained here, the new pivot row, 0, 1, 7/22, negative 3/22, then here 450/11. If our answers are going to be negative all in the Z row, then it means we have actually achieved our last in a simplex table. So let us see. This is 0, negative 80/7 minus this one. This one was supposed to, we are still supposed to multiply these two. We haven't multiplied. So this is 0. Then we have negative 80/7. Then this one multiply by this one supposed to give you a value of 40/11. We should actually, 40/11. No, negative 40/11. Sorry. This one we shall have 120/77. Then multiply these two, we shall have negative 36,000/77. Then again you minus these two to get new Z. 0 minus this is supposed to give you 0. This minus this is supposed to give you 0. This minus this is supposed to give you positive value over, then this minus this is supposed to give you 120 over 11. Then this minus this is supposed to give you a value of 68,000 over 11. As we can see that we don't have any negative value, so it means we have actually arrived our optimality solution, and we can all in fact be able to obtain now the final table as requested. Now we can comfortably now write the final simplex table and see how we can actually solve those particular problem. Like you normally have the solution variable, then later we have an element to do with product A, product B, slack variable 1, slack variable 2, then quantity solution. So we shall have these two. We can begin from what we can see, Z. Our Z is 0, 0, 40 over 11, 120 over 11, 68,000 over 11. Then our new A, and of course our A was replacing S2. See that our A was replacing S2 is supposed to be what we computed here, 0, and 1, 0, should be 1, 0, negative 1 over 11. You have 2 over 11, then finally we have 500 over 11. Then this one was B, which was replacing S1, and for us to get our S1 or the values for the S1, we shall get back to this one here, in which we said that actually our S, which was the new pivot row that was replacing S1, which was B, shall have 0, 1, 7 over 2, 2, negative 3 over 2, 2, then 450 over 11. So we have actually achieved our optimal solution because we don't have any negative value on the Z row. And actually negative values on the Z row simply means that profit maximization function can still be improved further. So in this particular case, we have achieved our highest optimization. So in this particular working, you say that therefore we need to produce the following units of A and B to maximize the revenue. So product A, we need to produce 500 over 11, which is equivalent to 45.45, approximately 45 units. For product B, we need to produce this quantity solution of 450 over 11, which is supposed to be equal to 40.9, which is approximate to 41 units of that particular product in order to maximize the profit. Now, we have come to the end of our particular lesson. And please, I would kindly ask you to subscribe if you find this video helpful. Thank you.